Hello students. So on continuation with the last part, we will be starting with the computational part of drift velocity. So let me write down what are the things. Let me summarize that what are the things that we have already studied. That we know that we are discussing about only the 4 electrons. So that is going to help us to find out the complete summary of it. So you want to the summation of all the random velocities is equal to 0. Second thing, we studied that the constant acceleration that has been observed or by the or experienced by the electron is going to be minus E by m, which is constant for all the electrons because mass and the charge of electrons are not variable, and a constant electric field is going to be experienced that has been created by the battery by each electron, right? So this is for a short duration of time. The most important thing is that this is for a short duration of time. So that's why velocity, average velocity or the drift velocity is having more effectiveness or having a more important, or it does matter us a lot for computational ease, right? Because acceleration is only for a short duration of time. Why? Whenever it gets some acceleration, at the next moment it is going to get another electron to be striked out, or it's going to strike another electron, or it is going to strike another atom. So again the process will start, right? So how many time we are going to put the acceleration, get the formula, and to go get those things, right? So this acceleration is for a short duration of time. So that's why the average velocity matters. That's why the average velocity matters. Actually it is like start, stop, then start, then stop, right, and so on. So this acceleration is constant, and the movement does takes place, and the movement does takes place for relaxation time. For relaxation time. If I say that this is the point from which our electron is starting, and it is going to be assimilated by an atom which is vibrating at its own location, let the initial velocity is u, right? And this particular point, you know that the velocity is equal to 0, but this is not going to be the velocity that we are going to take. NCRT has taken this velocity, but I told you that as if I'm talking about many of the renowned authors like David Griffith and SC Burma, so they have not considered this velocity, rather they have taken just before this, whatever be the velocity is there, let it be v, that is the velocity, and the duration up to this one is called as relaxation time. After this one is called as relaxation time. So let me write down the for numerical equation, and from this to this it is going to be experiencing a force of a. So I'm going to write down a acceleration of a. So can't we write down this equation as, for the first electron I am writing v1 is equal to u1 plus acceleration is constant and t1. Similarly, for the second one, we are going to write V2 is equal to U2 plus AT2. For the third one, and so on. And similarly, we will be writing for the nth electron, the formula is going to be UN plus A tau n. Clear? So in fact, can't we write down this velocity u v1 is equal to u1, and acceleration can be written as minus of ee by m tau 1. Minus of E by m tau 1. Okay, let us calculate the average velocity over the whole path for each electron. Let us calculate, I'm writing using another pen over here. Let us calculate the average velocity of each electron. Calculate the average velocity for each electron over the whole path from here to here, over the whole path. As we know that it is just like a particle that is moving. If the particle is moving with a constant acceleration, if the initial velocity u and the final velocity is v, then we can directly write down the average velocity as, u plus v by 2. So similarly, we can also write it for this electron as it is moving with constant acceleration. So we can write down the average velocity as, for a single electron I am writing down, then we can summarize it for the whole one. So I can write it down for the first electron. V average for the first one can be written as U1 plus V1 by 2. Similarly, for the second one we can write, and I am writing the for the nth one, V average for the nth electron is Un plus Vn divided by 2. Okay, so let's move to the next page. So let me continue this. So what is a drift velocity actually? It is the average of V drift is actually the average of all the average velocity, average of all average velocities. Average of all average velocity. So let's find it out, that drift velocity. So if I'm going to write it out, V drift, that is equal to V average for the first electron plus V average for the second electron. Hope it is very clear to all of you now. Plus V average of the nth electron divided by n number of free electron divided by n number of free electrons. Clear? So let's write it down. This derivation is quite important. Again, I'm going to take a small assumption over here, like so again for the simplification of the calculation, we can write V average for the first one can also be written as U1 plus V1 by 2. So can't we write down this V1? Can't we write down this V1 as U1 plus 81? Can't we write down this V1 as U1 plus A tau 1, right? So we can write down the whole expression as U1 plus A tau 1 divided by 2. In fact, we can also write it as U1 vector plus A vector tau 1 by 2. Clear? This is the average for the first electron. So we can write it out like U1 plus A tau 1 by 2 plus U2 plus A tau 2 by 2 and so on, divided by the total number of free electrons. So here I am going to do one thing. So it is going to be U1 plus U2 plus so on divided by n plus. Why did I take this as one side? Hope you can understand it now. Plus A by 2n, I am taking it as common outside, right? A by 2n, I am taking it as common outside, and tau 1 plus tau 2 plus and so on. Okay, tau 1 plus tau 2 and so on. Okay, here I'm doing one more thing. I'm simply dividing this n over here also. Now, can you imagine what is this? Can you recall this thing? This is nothing but it is equal to 0. These are the all random velocities. So they should give you a sum of 0. So final answer is equal to A by 2n tau. Tau is scalar, no? I just put this one. Okay, A tau by 2n. A tau by 2n. So what is acceleration? Acceleration is minus E of EE divided by 2m tau. Minus of EE divided by 2m tau. Clear? So this is your drift velocity. This is your drift velocity. I'm putting a star mark on it. This one is your drift velocity. So this drift velocity is a very important result that is going to help us to find out so many expressions, so many derivation in the further process. Clear? Okay. So this is one of the expressions for drift velocity. I'm going to find out one more important expression for the drift velocity, but the process is same. The mechanism that is behind the movement of electron is same. So what's the next method? I'm writing it as second part of it. As we know that same thing, let me start it with, so this is our electron. It was moving with an electric force of EE along this direction, and due to the continuous collision, it is going to observe a opposing force also. This opposing force is just like a friction link. Due to the continuous collision, opposing force is present. Opposing force is there, right? Okay. So this is moving in this direction with EE and opposing force is this Fs. You know that this opposing force is directly proportional to the speed. It is directly proportional to the speed. Why? More number of collisions. If it is going to move with a very faster speed, so the number of collisions will be more. So more the value of V, more collisions are going to take place and more collision will be there. More is going to be the opposing force. So we can write the acceleration, and this electron has some mass m. Acceleration is EE minus kb divided by m. Acceleration is equal to EE minus kb divided by m. K is a constant actually. If I write Fs is equal to kv, k is a constant. If we convert this proportionality into equality, it will become a constant kv. So due to the acceleration, speed of the electron increases, you know, due to acceleration, speed of electron increases. Of course, speed of electron, even if it is smaller in the initial condition, the speed of electron increase. If the speed of electron increase, as a result, what will increase? This kb or the opposing force will also increase. As a result, Fs also increases. Fs also increases. If Fs also increases, you know, more and more friction is going to drag it. So at a moment, at a particular time, so we find that at a particular, so acceleration will also decrease, right? When the speed of the electron increases, then the other result Fs also increase. So this acceleration with it was accelerating will also starts to decrease. At a particular time, we found that at particular time or instant, we found by decreasing, as a result, the acceleration will also decrease. I am writing down, the acceleration will become equal to 0. If the acceleration becomes equal to 0, then you know that that electron is going to move with constant velocity. That electron will start to move with constant velocity. Hope it is very clear to all of you now. Acceleration will become equal to 0. So if the acceleration become equal to 0, so at this point we can directly write down that kb is equal to ee. Both the forces are going to balance each other, right? So this speed is called as drift speed. The speed is called as drift speed, which is nothing but it is equal to ee by k, which is a constant. Okay, so we can also express it in another form, that is mu times of E. This constant E by K is called as another constant, that is called as mu, while mu is known as mobility of, okay, and it further moves with the constant speed. And you can directly say that this speed is directly proportional to the applied electric field. So drift speed is directly proportional to applied electric field. Drift speed is directly proportional to applied electric field, and mu is a constant, and this constant mu is called as mobility of free electron in the metal. It is called as mobility of free electrons in the metal. Okay, and it depends on the following parameters. It depends on the lattice parameter as well as, and on the temperature of the metal, and on the temperature of the metal. Okay, so this one is your drift speed. So this is another expression. Clear? Let us understand what is the relationship between the drift velocity and the current density, which is again another important relationship. Relationship between drift velocity and current density. Drift velocity and current density. In fact, it is going to be a derivation. So just listen to me very carefully. I'm going to draw a conductor here. Okay, the total length of the conductor is, let it be L. Okay, and this conductor is connected to an external supply voltage of EMF V. Okay, fine. So let the current is flowing in this way. That doesn't matter. Now the question is that I'm going to take that many number of electrons are there that is moving. I'm going to take only one electron to show that what exactly is happening over here and how the relationship is established over here. Let me take, there is a cross section. Let it be at this point, I'm going to take a point, it is A, and another point, and at this point the electrons are moving with a drift speed of Vt. Every electron is moving with a constant speed Vt. So the electron which is entering this region with a constant speed Vt, in 1 second I can say that it is reaching from A to B. So let the area of this cross section is S. Let S is the cross sectional area of this cross section. Let S is the cross sectional area over here. If I say that one electron is moving with a speed of Vd, so in 1 second, the distance traveled by the electron, distance travel, that is nothing but it is the distance between A to B. Can't we write it as the speed of the electron multiplied with time? Because it is constant velocity. So we can write down Vd and time is equal to 1 second. So can't we write it down as Vd meter? Yes, it is Vd meter. So I'm going to write it as Vd or only Vd unit. Vd unit. Right? So the distance travel is going to be equal to Vd. So let me find out. It's a very important concept over here because if you are not clear about this, you are going to continuously make mistakes about it. I say that the number of electrons per unit volume present inside the conductor is, let it be n. Let the free electron density, it is called as let the free electron density. Let the free electron density, what is the meaning of it, is equal to n number of electrons per unit volume per meter cube is called as free electron density. Okay, so the distance traveled is Vd unit. So how many number of electrons are crossing the section per unit time? Step by step we'll be finding it out, that how many electrons are crossing the second section per unit time. How many, question, how many electrons are crushing the section per unit time? Why we are doing all these things? Because we know that current per unit cross sectional area is current density, right? So that's why. How many electrons are crushing the section per unit time? Let's find it out. Per unit time. So it is equal to, how many electrons are crushing? We have to multiply the volume with the number of electrons per volume, unitary method, n into the volume. So how much is the volume? Area is S, distance is L, so the volume of this part is going to be S into Vd. So we can write NS Vd. We can write it as NS Vd. Clear? Second step, charge flown per unit time is current. So we can write current is equal to charge flown per unit time. Charge flown per unit time. Charge flown per unit time. So how much is the charge? Charge is equal to, this is the number of electrons, this is the number of electrons, so charge is going to be number of electrons multiplied with charge of one electron. So we can write NSVD into charge of one electron divided by 1 second, because time is 1 second. So the amount of current that is going to flow is NESVD. In many of the books it is also written as NEAVD, is again going to be a very, very important expression that has to be used. It's going to be used in many of the numericals. NEAVD. Third one is to find out the current density. Now Last one is to find out the current density, that is equal to I by S, or we can write it as I by A, which is going to be a very important expression for which we are finding out the relationship. That is going to be NES VD divided by S. S and S are gone. So final answer is NEVD, right? So NEVD is equal to the current density. So we can write down the current density as J by NE. We can write down the current density as J by NE. Clear? So this is the relationship between the current density and the drift velocity. We will do some couple of questions as numericals. So the first question that is given here, it says a current of 16 ampere is passed through a conductor in which the concentration of electrons is 4 into 10 to the power 28 per meter cube. And its cross-sectional area, I'm directly writing down the area A as 10 to the power minus 5 meter square. Find out the drift velocity of the electrons. Find out the drift velocity of the electrons or the free electrons. So let's do it. It is given that what are the things are given over here? Current is given and your electron concentration is given and area is given. Electron concentration is given and the area is given. What we need to find out? We need to find out the drift velocity. So as we know that drift velocity is equal to J by NE, J by NE. Okay, and we know that J is the current density, which is equal to current by area or A, I by A. So can't we write down VD is equal to J divided by NE, which is equal to I by N E A. So everything is given over here. I is 16 ampere. Number of electron concentration is 4 into 10 to the power 28. E is equal to 1.6 into 10 to the power minus 19. And area is 10 to the power minus 5. So the final answer is coming out to be 2.5 into 10 to the power minus 4 meter per second. That's the answer to the question. Okay, another type of question. Just another type of question that is based on that when the free electrons per unit length is given, how to deal with the question. When the free electron per unit length is given. Let me take one question. The question says that a wire carries a current of 1.6 ampere. A wire carries a current of 1.6 ampere. If free electron per centimeter, it is given that if free electron per centimeter is given as free electron per centimeter is given as let's take it as a 2 into 10 to the power 22 per centimeter. Okay, what is the drift velocity? What is the drift velocity? Okay, let's solve it. Let's check that what are the things are given over here. We are required to find out the drift velocity. I is known to you. The relationship between I and Vd is I is equal to NEA Vd. But what are the things are given? Area is not given. Number of electrons are given. And the drift speed you have to find out. Current is given to you. So instantly we'll be writing down what is the meaning of this N. This N means the total number of electrons per unit volume. So that means area into length. What is the meaning of N? N is total number of electrons by A into L. So can't we write it down this small n as, can't we write down this small n as N by AL into E A VD, where A and A are getting killed. So there is no need of area now. So we are getting it as N by L EVD. Eventually we are given this value actually. We are given this value actually. But this is given in the form of centimeter. Let us convert it N by L into meter. That is 2 into 10 to the power 24 per meter. Per centimeter it is 22. Per meter it is going to be 24. Clear? So we have to find out the VD value. So VD can be written as, so we can write down the VD as I into L by N, right? I into L by N into E, right? So let's see what are the things are given. Just put it in the equation, we'll be getting the answer. I is given as 1.6. N by L is given as 2 into 10 to the power 24. So we are going to write it as 1 into 2 into 10 to the power 24 into 1 by 1.6 into 10 to the power minus 19. Clear? These things are getting cancelled out. So finally we are going to get the answer as 0.5. You can calculate it later. 10 to the power minus 5 meter per second. That's the answer to the question. Clear? Okay. So that's all for today. I'm going to share the question for the practice. So the next part we will continue in the next class. Thank you so much.